Hello. This will be a microservice development series using Java Spring Cloud. So we'll start with the basic one microservice and we'll work our way up. So basically, we're going to do these microservices communicating with each other. But we'll start with the basic one, which is now the users. So before we start, let's understand first some terms in microservice development. First is the HTTP, which is the protocol for performing action on a resource identified by the URL. So in terms of the different method that our microservices and Spring Boot in particular accept, we have the get, post, put, patch, delete, and some other not well known method, which is head, option, connect, and trace. So on this first series of ours, we'll just be focusing on the four basic method, which is get, post, put, and delete. So you use get to retrieve data from the server. The post is used if you want to send something to the server and you want your service to process those data. The put is used to update or replace existing resource on the server. The patch, which is similar to put, but it used to apply to partial modification on an existing resource. Then delete is used to request a removal of a resource from the server. So let's start. Let's create first a basic micro service from start Spring IO. So I will just choose Java, Maven, and version 313 group ID, my company, and artifact, say MC users service. The prefix MC here is just prefix for my company. Then package name, jar, and then the version. So let's then add our basic dependency, which is the web data. We're going to use H2 for our database, but you could use other database. It will be easier if we use H2 for our just for development. Then Lombok. Okay, let's generate, and then let's open this project in our IDE. So I'd like to start with the structure of the project. Okay, so basically we have our package name, my company, and then we have the main. So inside this package, we could create a different packages that will include all our classes specific to the purpose. So we have the controller, service, we have a constant, we have the repo, story, then we have say model, So inside the model, we could create two sub folder or packages, which is DTO, and the other one the entity. Then we also have the say folder for our exception. Okay, then we'll work with this structure for now. So there are different kind of architecture that we can use for creating our microservice. So basically, this is one of those architecture, which is just a basic MVC pattern. So I'd like to work from the lower down going up. Others would like to start on the controller. For me, I usually start with the YAML, I mean on the config file, and then go up to model, repository, services, and then the controller. So this is just a preference. So you can also code it in such a way where you're comfortable with. For the config itself, I like to work with YAML since the that properties is very verbose. So I'm just using the YAML version. So let's start first setting up our config. So I'd like to change the port to say 9000, and then set up our data source, JDBC. So we're using H2, and we'll just save it to the file. Say users, then username SA. We don't need to define the password, but we need to put it there. And driver class name H2 driver. This one should be indented because sorry, this one should be URL. Okay, then here is GPA database platform, which is we need to define which dialect are we going to use. So H2 dialect, and additional settings, DDL auto. So means we're going to auto create our table in this case. And then let's show the SQL that this GPA execute. Then let's expose the console of H2 there. Okay, so the configuration we already set up. Let's start with the entity. So for our entity, we're going to create a user. This one is of type entity, and then there's a problem with having your class as user. Seems like databases is not able to correctly create that one, since some databases as user as a reserved word. So let's name the table as account. So that's how you rename the table. You just specify the name. Then we'll have three attributes based from our diagram: the ID, name, and the email. So for the ID, let's use the UUID. So this is your ID. Then you have private string email, and then private string name. And then for the use for the ID, let's specify that this is our ID, and then generated value. The strategy is we're going to use UUID, generation type. Let's specify here let's use Lombok to generate setter and getters, and a default no parameter constructor. And of course, since our key for searching is the email, let's specify this one as unique. Okay, so that's it for our user entity. Then we could create the user model, repo, user repository. This is an interface. So it after extends GPA repository. Then we specify the class or entity name, and then the second parameter is the type of the ID, which is in this case UUID. Right, so we already set up our repository. Okay, so let's continue. So then I'm going to move to the DTO. So I'm going to name this DTO as user DTO. We're in this user DTO. Let's put again the data and the args. So it will only be email and name. So we don't expose the ID itself, since the ID is specific to our database column. So we're only going to require the user to input the email and the name. Okay, so after this one, let's maybe move to the controller. So I'm going to name this controller as user controller, and this is a REST controller. Then we could create here the base mapping, which is in this case say API v1 users. As we go to the endpoint, let's start first with post, so that we'll be able to create the record itself. Post mapping, say public. Let's return the ID that our user has created. So create user, and then here we require the request body, which is of type user DTO. There. Okay. So the usual practice is instead of declaring our repository here, we could actually do something like this: user repo, then repo. But then the correct way is create a service class and call that service class on your controller. So let's create that now. So let's create a user service. Usually, again, standard practice, create an interface, and then based from that interface, implement this user this interface. So here we have string create user, which requires a user DTO and user DTO. Then usually we create here a package named EMPL, wherein on this package we create user service implementation, implement the user service, which is the interface. So then it requires us to implement the method, which is the create user. Then from here we annotate this class as a service class. Okay, so we have now our create method. So from here we could auto wire the user repository like this, but it's very hard when we go into testing. It's very hard to test this one, so better practice or approach is create or auto wire it through the constructor. Okay, so user repository, and then here create a private user repository. Okay. Okay, there. So we have already auto-wired our user repository. Others would actually type in auto-wired in the constructor, something like that, but it's actually not required, since by default Spring will auto-wire any component passed to the constructor on a component class. So from here, since we're now on the service class, you can do your business logic here, whatever you want to do. And let's create the object. I mean the record itself. But then if you notice, we pass in user DTO. But user DTO, it's just a normal object that we pass around. The one that we're going to save in the database is the user. So what we need to do is we need to convert this user DTO into a user. So how to do that? The easiest way to do this is using the object mapper. So we could declare object mapper here. This one. And then we could again auto wire here in our constructor. Then this object mapper, right? Then from here, what we can do is object mapper, we're going to write value as string of the user DTO. So it will be becomes a string type, JSON type, and then we could write it to the, so read value the JSON and convert it into a user class, user.class. Okay, right, let's try this first, putting inside the, oops, so this is a user from the entity there. So then okay, we need to return the user get ID to string. Okay, So from this one, from the catch block, we could return or throw the exception altogether. But then we could also create an exception class specific to this project. So let's create now a user exception class. Okay, and this user exception class extends runtime exception, and let's specify here the code, the message, and then the HTTP status. There. So we need all args. So it will create a constructor with this argument. Okay. And in this case, after catching the JSON processing exception, we could throw the new user exception. So it requires the code and then the message, which is say, let's just, and then the status, HTTP status, say this is bad request. Okay. Okay, so we'll go now to the controller. So on the controller itself here, again, you can auto wire the service, or you could pass it as parameter to the constructor, user service. Take note that we're creating an interface, not the actual class itself. So here, private final user service, and then this user service. Okay, and then from here, you can just say return user service, create user, and pass in the user DTO. All right, our service is running. But in order for us to test this one, we need to do curl or postman. But I would rather use the one available in Spring itself, which is called Spring Doc, or before it was called Swagger. So let's add that library. So I'll stop this service for now. Let's add our dependency. And then let's just use a version 2.0.0. Right. Okay. Then after loading this dependency, let's try to run the service again. All right. Before we could test our application, I just want to add something on the service class. Oh, we missed something here. So we're actually converting the user DTO to user type, but we're not saving it. So since on our constructor, we already injected the repository, so we'll just say repo save and then the user. Okay. Then let's try to run. Okay, our service is up. So the H2 console can be access from this endpoint, localhost the 9000, which is our port number, and then the h2-console. So you just then specify the JDBC URL, which is the URL that we define in our application YAML, which is users, then connect. Okay, so then we already have here the account table. Currently, there is no entries. So let's go back to our Swagger. So here we'll try to hit this endpoint with the email and the name as parameters. Execute, and then it returned the ID as we define in our service. So let's go to H2 console, then run, and then you'll see that we already have the ID, the email, and the name saved on our database. All right. So after this one, post mapping, as we see here, used to send data to the server and process it. So we'll continue with this development to get data, to update data, and then to delete data. So I went ahead implementing the different functionality aside from the post mapping that we created earlier. So we have first the get users. This one will get all users from the database. Now, if you notice, I pass in a pageable. We pass in pageable such that if we query everything, we have to limit the size itself. We cannot just query everything. It might throw us an OOM. So basically, we're doing defensive programming here, where we specify the page and the size that we're going to query. Then the next mapping is on get a user, specific user. Now, where we have made email as our unique identifier. So from the email itself, we're going to query the user. And the next one is delete. Basically, it just tell us that we want to delete a user based from his or her email. Then the last one is put mapping, or updating the user detail. Since the email is our unique identifier, we shouldn't be updating it. So in this case, we're going to only update the name. But then here, I created another DTO, which only specify the name itself. So if we go to the service implementation, let's look at here. This one is already we're familiar with, the saving. The get users, again, find all, but then we pass the pageable. And then based from the number or the size of the page or the record that we're going to return, since the find all will return a user type, okay, the entity itself, but then we're returning a user DTO. Since we don't want to return our data transfer object, the entity, it's a good practice that we actually use a DTO to return back to the client itself, or to the call from the API. So we convert our user into a user DTO class, then return that one. So here we're querying all, the users and then converting it into user DTO. Then the user itself here, this is a simpler way to do that. Instead of using stream, here we just use the optional. So we created a new method, find by email, in the repo itself, find by email. Take note, find by is a keyword in GPA, such that you're allowed to create a query automatically based from its property, and email is our property. So find by email allow us to query the email column, and then we just return an optional type, and then based from that returned value we check if it's actually present, means the user exists. If the user exists, we're converting it into a user DTO, since we're returning a user DTO. So here, it's another way to map property from one object to another. So in this case, we use bin util, then return the user DTO, else we just throw a runtime exception for now that there's no record found. Then on the delete, if you notice, there's a transactional annotation here. So by default, GPA won't allow us to delete a record if it's not within the transaction. So when we do a delete by email, this is our implementation. Again, delete by is a keyword for the GPA repository, and email is the property. So this method name allow us to delete a record by column email. Then it returns a numeric value, how many record was deleted, and then here I just check if there's a record deleted, return true, else throw a runtime exception. Then for the update user, so again, we find by email and then map it to the user entity, map it to the user DTO. I mean, we set the user value found, and then if you notice, there is no something like repository save. Since we are inside the transactional method, by default, GPA will save the record automatically to the object you retrieve when the method ends or when it exits the method. So we don't need to write here repository save, else we'll just throw an exception that there's no record found. All right, so let's test it out. So we'll start with the saving of record. So this is the old record that we actually already saved. So let's try another one, say Jane Doe, and here Jane Doe, saved. Okay, and it returned the ID itself. So let's query those record. Now if you notice, we're required to actually send the page, the size, and the sorting. So from here we're specifying that we're going to sort by email and the size is 10. Execute, and then we return the 3 records. Okay, the Jane Doe, John Stark, currently it's Jane Stark, so we need to update this one later. And Peter Parker. Okay, then let's try to get by specific email. So let's search John Stark, execute, and then a record is returned. Take note it's Jane Stark. So let's try to update it. John Stark. So instead of Jane Stark, we'll change it to John Stark. Execute. So returned the ID. So let's query it again. Currently it's Jane Stark. Then if we execute it again, it's now John Stark. Then for deletion, let's delete the John Stark record. Execute, and then it returned true. So can we query it again? Okay, let's query John Stark. Click, and then if you notice, its response status is 500. Now if you look at the code for the query get user, it says runtime no record found, but here if you notice, the response is internal server error. This is where we are going to customize our error handling. So to customize this one, let's create an exception here. In this case, we have what we call the user exception that extends runtime, and then it requires an error code, message, and HTTP status. So here, let's try to change this one to throw new user exception. And then for record not found, we can change this one to 404. Then the message itself, so no record found. And then the HTTP status, which is not found. There. Oops. Not found. Okay. So aside from this one, we need to customize also what we call as exception handler, or the advice in Spring, so that we can customize the error handling sent. So let's try to create another class here, which is our API error response. We're in here. We could say UUID. Let's just define UUID, the error code, the message, and then the path. Okay. Okay, so after creating this API error response, we need to create a REST controller advice. So let's just create a new folder for this handler or advice, and then we'll rename it as application exception handler. Extend response entity exception handler, and this is a REST controller advice. And then we just need to specify the order that this will be the highest ordered. Right. Okay. Then we need to create a method which is called exception, which is annotated with exception, and then handle the exception that we throw. So on our case, we're using a user exception class. Then the response entity, handle application exception, final user exception, then final servlet request, this one. Okay. Then from here, let's create first a UUID to string, then API error response. So we need the UUID, the error code, which is the exception get error code, then the message, and then the request URI. Okay, then return new entity with the response and the exception HTTP status. Okay, all right. So with this, we are able to customize our exception handling. We're in for now. It's showing this one, response 500 and this response body. So let's run this. All right, our service has started. So let's test this one again. This John Stark, let's query everything first. Here, let's query. Okay, so you have only Jane Doe and Peter Parker record. John Stark is non-existing. So earlier, the error that we get is this one. So we created a new REST controller advice that gives us back this API error response. So let's try. Okay, so if you notice, the error response now is of 404, and then you have this custom response, the UUID, error code, message, and then the path. So we have customized the exception response from our API. Okay, so that's it for this microservice series, wherein we actually started working with the JPA implementation for CRUD operation with the account users. So happy coding!